Question says 32% of a 50-gram alloy is gold. How many grams of gold are in this alloy? So in these types of problems, the percent is the rate. And the rate will be a ratio of some kind of amount of substance 1 to the total amount. So in this case, we'll say it's the amount of gold divided by the total amount. Alright, so what they're saying here is that 32% is the amount of gold which we don't know divided by the 50 grams of the alloy. We want to solve for the unknown amount of gold. So we want to rearrange the equation by multiplying the 50 to the other side. Now when we do that, we'll get 32% times 50 grams, a rate times an amount. And we have to be able to turn that percent into a decimal so that we can plug it into calculator. The formula above helps us do that. It's a formula for converting any decimal into a percent or a percent back into a decimal. All we have to do is plug the percent into its proper place, and then we could solve for the decimal version of the 32%. So the way that works is you've got n times 100% equals p%. We'll plug in the 32 over here, and we want to solve for n, which is the percent as a decimal. What ends up happening is we're going to divide by 100. And that's the meaning of a percent sign, is it's per 100. So if we want the decimal or the fraction, we would do this. It'll be 0.32 as a decimal. And so we want to go back now to our problem and just replace the 32% with 0.32. And it ends up being 16 grams of gold. Next one says, a 200-gram solution contains 25 grams of salt. What is the percent concentration of salt in this solution? So for that, we can find our percent just by dividing the amount of salt in the solution divided by the total. So it's going to be 25 grams of salt divided by 200 grams of the total solution. I get 0.125. However, we have to keep in mind that that is a decimal version of the proportion of salt. And so we would now want to use that formula above, and we'll say n times 100 equals p%. We have to this time plug in the 0.125 over here. And we'll actually multiply by 100 to get 12.5%. And that'll be our final answer. It's 12.5% salt. This one says a mixture is made by mixing 25 liters of a 12% acid solution with 15 liters of an 8% acid solution. What would be the final percent concentration of this mixture? Alright, so let's set this up similar to the way we had set up some previous ones. We've got a total percent that we're trying to find, and that's like a rate. And then we want to multiply that by the total volume of the solution. On the right hand side of the equation, I'm going to put the 12% rate times its volume, and then we'll do the 8% times its volume. So it's going to be like a weighted average. Alright, we can eventually solve for P, percent. So let's add our volumes together. This is the total volume of the whole solution. The volume of the 12 is 25 liters. And the volume of the 8 was 15 liters. So the total percentage times 40 liters equals, we're going to want to change these into decimal form so that we can multiply them on calculator. So I get that the final percentage here as a decimal will be 0.105. But we want to change it into a percent. So let's multiply by 100. It'll be 10.5%. And that should make sense. It should be something between 8% and 12% since it's a weighted average. How many milliliters of pure acid must be added to 50 milliliters of 15% acid solution to make a 40% acid solution? This is going to be really similar to the one above. Same type of setup. We've got a total percent of the final solution. We want to multiply that by the volume of the total solution. And that's a weighted average made up of, let's see, there's a pure acid, so that's basically 100%. And we'll multiply that by an unknown volume. That's what we're trying to find. And we're also adding in a 15% solution, so it's diluted. And that's 50 milliliters. Okay, so one thing that makes this one a little bit tougher is we don't know what the total volume is, and we don't know what the volume of the pure acid is either. So we do know what the final desired percentage is though. That's 40%. For volume of the 100, I could just put in a variable such as x that's easy to work with. And now I got to figure out what to put in here for the total volume. And based on what we had done in the past, hopefully it's clear that what we want to do is take our individual volumes, the x and the 50, and actually just add them two together. Now we have our equation down to just one unknown. We can change the percents into decimals. And I'll remove any units just to make it easier to work with. And then we want to solve the equation for x. Okay, so we'll get subtract 7.5, subtract 0.4x. I'm moving the 7.5 over to here, and I'm moving the x's over to the right. I get x is approximately 20.8 milliliters. So 20.8 milliliters of pure acid would have to be added to 50 milliliters of a 15% acid solution in order to make a solution of 40% concentration.